Choosing a reference point. An object's position may change relative to one reference point, but may not be moving relative to another reference point. When describing motion, it's important to include a reference point so your description will be clear. Describe the reference point that could be used to indicate that the man in the boat is not moving. And describe another reference point that could be used to show that the man is moving. Think about it. So an example that would show that the man is not moving in the boat. So we could say the boat itself shows the man is not moving. Whereas we could also use the boy to show the man is moving. Determine the time interval. The time interval is the difference between when an event begins and when it ends. SI units for time are usually in seconds, and the symbol is T. So our equation is T, delta T, and again, delta means change. T is our time. F, final. I, initial. Use the equation above to find the time interval for your science class. So say our science class begins at 9:30, and that's our initial time, and our final time is 10:30. So if we take the change in time to be 10:30, subtract 9:30 equals 1 hour. Uniform motion. Uniform motion is the motion in which the object displacement is equal for each time interval. Uniform motion is rare because friction forces usually act on an object. Why does the motion in diagram B show uniform motion of the billiard ball more clearly than the photograph in A? Think about it. Well, our number line has numbers that can be used as reference points. Whereas our picture above does not. Graphing uniform motion. Position time graphs show the position of an object over time. When motion of an object is a straight line on the position time graph, we have uniform motion. Which graph represents an object that has uniform motion? Think about it. The graph on the left shows uniform motion. All the dots are along the line, whereas the graph on the right, the dots aren't on the line. Analyzing a position time graph. A positive slope on a position time graph indicates an object is moving in the positive direction. A negative slope on the position time graph indicates an object is moving in the negative direction. A zero slope on the position time graph indicates the object is not moving at all. So I'm positive when I'm increasing, I'm negative when I'm decreasing, and if I'm staying flat, I'm not moving, and I have a zero slope. Is the motion of the object in the graph positive or negative in this position time graph? Think about it. The object is negative. Is the motion uniform, and how do you know? Think about it. The motion is uniform because all the dots are plotted on the same line. So we have a straight line. So that shows uniform motion. Let's review. Reference point is a starting point used to describe the location or position of an object. Uniform motion is a motion in which an object's displacement is equal for each time interval. Position time graphs indicate if an object is moving in the positive direction, negative direction, or not moving at all.